Hi, everyone. Thanks for joining us today for our webinar. Just a few housekeeping items. If you have any questions, please feel free to type them in the Q&A box, and we'll take a look at them at the end of the webinar. We'll get to all of them. Also, as with all of our webinars, this will be available to watch on our YouTube channel after it is downloaded. So today we welcome Chip Houmes from Precision Laboratories. Chip has almost 40 years of experience in the agriculture chemical field, and he'll be leading us through a webinar on Total Spray Droplet Management. This will incorporate foliar surfactants, drift control, rainfastness, pH, and bicarbonate. And this is all from our new product line with Precision Laboratories. So welcome, Chip.
Lauren, thank you. Appreciate it. So yeah, we're welcoming you to the Tessman webinar today. I see from their logo that they're celebrating their 70th year in business this year. Precision is not too far behind. We started in 1962, so we're a little younger than that. So that looks like it's just 58 years or so. I've been with Precision for 22 years. Before that, I was with Ciba-Geigy and Dow Chemical and a few of the chemical companies. But today we're going to talk about Total Spray Droplet Management. And just previous to this, we recorded one on soil surfactants. And Precision is all about surfactant chemistries. In this talk today, what we want to talk about is how to manage the sprays coming out of your spray tank. We believe that the efficacy and safety of spray applications can be improved by managing factors in your tank through the air and then onto the target. We call it Total Spray Droplet Management. There's a lot of factors that impact your performance, keeping an integrity of your spray mix when it's mixed into the tank, giving the best coverage as it comes out of the nozzles and hits your target plant, whether that's turf or ornamentals. And then in the general mixing and handling, a lot of these chemistries will also help within the spray tank itself. Surfactants help break surface tension. And on this leaf, you see the water is wanting to bead up. Water is attracted to itself. And what we're wanting to do is break that surface tension and improve the spread and spray coverage so that you get the most efficacy out of the chemicals and fertilizers that you might be applying. Without an adjuvant, the water droplets want to beat up on top of the leaf surface. With a surfactant or an adjuvant, we will help spread it out, and it's going to find entry sites and help promote penetration through the cuticle, past the leaf hairs that might be present on some weeds and crops or plants. This is a soybean leaf, but it's indicative of most leaves. It's got a waxy cuticle, and you can see the water's beaded up on the leaf by itself. When we add fertilizers to it, maybe it spreads just a little bit more, but not much. And then when we add an adjuvant or surfactant chemistry, you can see it really start to spread out. Those same three droplets now are giving much better coverage. So you can imagine if it was a sprayer, you're going to have full coverage of that tissue. The other advantage is when an adjuvant or spray droplet dries or a surfactant droplet dries, it's going to be in a pliable kind of a film, waxy film on the surface that's going to continue to be absorbed. But when herbicides and certain pesticides dry, they dry into more of a crystalline substance like 2,4-D here. In the middle is dried, and it's not going to be absorbed as readily into the plant. So when we mix the adjuvant with the 2,4-D, now we still have that waxy, pliable condition that's going to be absorbed more uniformly and for a longer period of time, because the 2,4-D in the middle, the crystalline, would have to re-wet to be absorbed. The other aspect of spray coverage, and this is your typical spray paper with each of the purplish drops showing where the water droplets are hitting. Obviously, nozzle selection and pressures and things, we're not going to delve into that today, but getting the most spray coverage is going to help you get the best efficacy. Just as an example for that in performance, this was a study we did at Michigan State University using Trimet Classic, a typical 3-way herbicide, and applying it by itself and applying it with a surfactant added. And you can see that we're getting about 20% better efficacy here. And that's typically what we see, is we can improve the efficacy both in overall weed control or disease control, insect control, but also it's just making it more consistent, especially on hard to control weeds and just getting the most activity you can out of it. As we look at things that impact our sprays, besides the surface tension of the water itself and getting better spray coverage with surfactants, we really should also be looking at water quality. In the United States, there's a lot of pockets of hard water, and that hard water can help tie up pesticides and actually break them down and make them less active. The water issues we're dealing with, again, surface tension and the molecular bonds that water has to itself and trying to reduce those with the surfactant. And then we deal with the pH or the acidity or alkalinity of the water, along with the hardness of the water and the bicarbonates that are present in that water, tying up pesticides and making them less effective. And herbicides, or excuse me, and nutrients as well. pH and bicarbonates in the spray water can affect your tank mix stability. Bicarbonates can actually tie up chemistries, and then they interact and basically decrease the effectiveness, either in their overall performance or how fast they work. So what's the best pH for your spray water? Typically people say 5 to 7. However, when we deal with some of the weak acid chemistries like 2,4-D or glyphosate, your 3-way herbicides, those really like lower pHs, even maybe down in the 3 to 5 range to be most efficient. We suggest that you get a pH of your water, but it's really best to get the pH after you fully mixed your tank. If let's say you started with a water pH of an 8, but when you add nutrients to it, if you add calcium, say, you're going to raise the pH. If you add an iron, a lot of times that's iron sulfate, that may lower the pH, as well as certain herbicides and insecticides can also change the pH of the tank when they're mixed together. Most city water is above 8. So I'd encourage you to look at the pH of your water. You can buy a pH meter, or you can even just go to a pool supply or aquarium supply store and buy litmus paper. You don't need to know the decimal points. You just need to know, am I closer to 7 or am I closer to 8 or 9 or where am I at? Water quality in the tank. Usually we're falling somewhere in this range. Very seldom have I seen anything over a pH of 10. A lot of times though, we're up in the high 7s and 8s, maybe approaching 9. And that's not a great environment for most of our pesticides. We want to be below 7 for most tank mixes. And when you get above 7, you increase the potential for what's called alkaline hydrolysis, which means basically the chemistries are being broken down because of pH. As we look at hardness and bicarbonates, though, now we're talking about elements that actually can affect the efficacy. They actually tie up the pesticides. They bond with them and make them less active. And so calcium, magnesium, sodium, iron, aluminum all can bind onto your pesticides and reduce their effectiveness. We had a story from a company that was a customer of ours out in the New England area. They had been spraying home lawns as a lawn care company. They mixed up a big 500-gallon tank and were pulling out of that all day long. They started getting callbacks, and when they evaluated that, they found that almost all their callbacks came from their afternoon applications, especially late afternoon. And we pulled the pH of their water, and they were up close to 9, and they had a high bicarbonate level. And what we did was went in and acidified their solution with one of our products, and it gave them much more uniform performance all day long. So pH is an indicator of water hardness, but ideally we not just test for pH, but we look at water hardness as a possible test as well. Because even Purdue University and several others are talking about how the water hardness basically attach to the pesticides, and they bind up, and they either make too big of a molecule to enter the plant or render them ineffective. As a chart, I guess when we look at herbicides in general, and 2,4-D, I keep pointing it out, but that's the largest single component of any of our 3-way herbicides that we're using. It wants a pH between 3.5 to 7, and we want to be below 150 parts per million of hardness and bicarbonates. Banville, dicamba, pH of 5 to 6, again below 150 parts per million. SureGuard, pH of 7 is fine, but again, bicarbonates can affect it. Glyphosate, or if you've gone to alternative like glyphosate, both of those want a pH of maybe 6 to 8, which is a little higher pH. But glyphosate is dramatically affected by bicarbonates. As an example to that, almost every application in ag with the GMO crops and having glyphosate so widely used in agriculture, all the farmers are throwing something in the tank that's going to address hardness in the water. They call it water conditioning. Data-wise, when we look at this impact on pigweed performance, recognizing that pigweed's probably not a big problem you have, but indicative of many broadleaf plants, here we're showing the impacts of bicarbonates on 2,4-D in broadleaf weed control. And you can see especially magnesium, but most importantly calcium, is very dramatically impacted. All we did here was condition the water, showing you what the hard water did. And so the pigweeds, the broadleafs, were able to survive in the hard water sprays with 2,4-D versus when we tie up the hard water and bicarbonates, now the herbicide can be much more effective. Same thing on grassy plants. Here's some studies done with glyphosate. Again, showing survival is much greater when you had hard water, and we had much better weed control when you address the hard water and condition it and tie up those bicarbonates. Not only herbicides are affected, but also insecticides are affected. This is looking at pH sensitivity here. As an example, the middle one is Dilox, a rescue grub material. At a pH of 8, it's not very effective. It breaks down. It is very subjective to alkaline hydrolysis. At a pH of 7, it's 10 times more effective. And orthene and 7 are similar, and many other insecticides are affected. So if you're in a tree and shrub program where you're spraying insecticides or doing things, I really would encourage you to use an acidifier, use something that's going to be good at addressing pH and bicarbonates. Fungicides are also affected. Here's dollar spot control with thiophenate methyl, Clarice 3336. At a pH of 5 to 7, we had 100% disease control. At a pH of 9, what is that, about 50% disease control. So again, many of our pesticides we're using can be impacted by this. Precision Laboratories offers a whole host of products that buffer or acidify the pH and also work on the bicarbonates. New Balance is a pH acidifier with a little bit of surfactant added if you just wanted to address this predominantly from an acidifier perspective. And then we have products like Chemstick LPH, which is a true spreader sticker for rainfastness that also has an acid added to it. Ellipso Plus is a soil penetrant chemistry, but it also works as a surfactant and as a pH acidifier. Compound is a newer product that we have. It's a surfactant with a pH acidifier and also has an oil in it that helps reduce drift. Our new product that I'll go into more details on is called LV. LV is a low volume surfactant or low volume sprayer surfactant. It can be used in commercial applications as well. It's a very effective surfactant and has probably our strongest pH acidifier in it. And then Deluxe is a chemistry that we have that's also labeled for aquatics. It's a surfactant that also has a pH acidifier but is safe to use if you were spraying, say, cattails or something around a pond and you needed something labeled for aquatics. Going on a little bit more about Chemstick LPH, it's probably our largest, most widely used product in lawn care. It is a true spreader sticker. A lot of people use the term spreader sticker and they think that's just a surfactant. The spreader part is a surfactant, but a true sticker is something that has polymers in it that help, once it starts to dry on the leaf, it avoids being washed off by rainfall. So for post-emergent applications, Chemstick LPH is really nice because it provides the rain fastness, it helps spread coverage, and then the LPH, we make a straight Chemstick if you want, but we also have the LPH Chemstick, and it has an acid added to it, so now it's addressing the pH and bicarbonates to get you the most activity. Another product that we have, and this one's more widely used in the golf market, but it's also I've been used with things like apple scab and certain other fungicide applications, is zinc. It can be used with fungicides, insecticides, PGRs, nutrients, and herbicides. But what zinc has in it, it does have a pH acidifier in it that's also addressing bicarbonates. It has a carbohydrate-based surfactant, so it's an organic-based, really nice surfactant. But it has an amine polymer complex that helps penetrate the cuticle and get it into the plant. And so zinc has been probably most widely accepted in the golf market, where they're intensely using fungicides on greens. It was originally targeted as a fungicide activator. to give you an example of that, here's chlorothalonil applied at 1.8 ounces, which is the lowest label use rate. And it was on a 21-day interval. Now that use rate should only last 7 to 10 days. So we knew that it wasn't going to hold dollar spot at the low use rate. What we wanted to show was how much better that application would be just by adding zinc. So we took the same low use rate of 1.8 ounces and added a pint per 100 gallons of zinc. And you can see 21 days later, there's a little dollar spot coming on, but it really increased the residual effects of those chemistries. And so when we get into situations that you're trying to get the most bang for your buck, or you're really fighting heavy disease pressures, zinc can really help you. And it would also have the same effect on anything foliar. We did studies on, say, Primo PGR. It impacted Primo very well. We had less clippings. But then when we looked at soil active materials, paclobutrazol, Cutlass, some of those PGRs that are soil active, it had no impact. So it's not negatively affecting the soil active products, but it's positively affecting the foliar products. This was some studies we did too. A lot of times when we look at pesticides and specifically fungicides, most of the companies, Bayer, Syngenta, BASF, they all recommend that we spray at 2 gallons per 1,000 square feet. And a lot of times people are down spraying around 1 gallon per 1,000 because they don't want to have to go back and refill as often, and it's just easier to get around. So in the middle of this slide, we can see straight Baileton on brown patch, the 2 gallon per 1,000 spray rate was better, much better than the 1 gallon spray rate. So you can see why the basic manufacturers might encourage you to go to 2 gallons for spray coverage. However, if you're down there spraying at 1 gallon, we took zinc, which is labeled here as PX056, that was the experimental number for zinc, and added it to Baileton, and you can see that we made the 2 gallons work better, but it was dramatic when we were looking at the 1 gallon, that we made 1 gallon of spray mix work as well as the 2 gallon. So now you can spray at lower spray volumes. And a lot of times when we're looking at backpack applications or typical hose end applications like a handgun, we're applying it at that 1 gallon per 1,000 rate. So if you're trying to get better performance out of that spray rate volume, using a good surfactant can really help you out. So again, whether it's commercial sprays, handguns, one of the other things we get into is people looking at other types of guns or these low volume sprayers. The low volume sprayer here, the Z sprays, the permagreens, the steel green units, those units are very effective and they're really catching on. There's a lot of lawn care companies that have now started using these, and some of the chemistries mix better in those than others, and some of those low volume sprayers don't have very good agitation. So what we were trying to come up with was something that would help the overall tank mix better together and try to also have the product itself mix in. And we developed a product targeted at low volume sprayers. It's called LV. It's targeted at low volume sprayers, but you could use it through any type of commercial sprayer and backpacks and those types of things. The thing about LV is it mixes really easily into the tank. It goes into bloom right away with minimal agitation. And the other thing, as I mentioned earlier, when you're addressing the pH of the tank, all of your other tank mix partners are going to mix more readily as well. So it's going to buffer the spray solution and tie up the bicarbonates. It's going to increase your spread. It's got a really good surfactant in it, and it's very easy to mix and use. Water conditioning is maintaining an optimal pH, and it's also tying up the bicarbonates, as we talked about earlier. It's going to improve the solubility and keeping the consistency in your tank, as well as getting it better absorption and uptake into the turf, into the grass or the ornamentals that you might be spraying. So here's a water test that we did, and this I find really interesting. So we look at the pH. The pH on the water that we tested was a 7.4. So just looking at it, you think, well, 7.4 is not that bad. We want to get below 7, but 7.4 is not terrible. But we go down and look at the bicarbonates highlighted there in the pink. The bicarbonates were off the chart at 373, really high. And so it's kind of surprising to me. I thought that something with that kind of bicarbonate level might be at a pH of 8, 8.5 or something, but it wasn't in this case. So we can't just look at pH as a single identifier. We probably need to be pulling water tests. And for 20 bucks, 30 bucks, you can send a water test off to like Logan Labs or a lab of your choice and do a water test looking at pH, hardness, and bicarbonates. And in this case, it was high in calcium. So the calcium is one of the more aggressive bicarbonates that can then go in and affect your spray mix. So when we added LV to the solution in these water tests, we started off at a pH of 7.4. By adding 1 pint in 100 gallons of water, we took it to a 6.1. And by adding a quart in 100 gallons of water, we took it clear down to 2.8. So in this recommendation, I'd probably look at something maybe around 24 ounces of LV per 100 gallons of water, and be able to keep your pH where you want it. So very dramatically affecting the pH. But the other thing was we looked at the bicarbonates. We started at 373. If you remember from my herbicide slide, we want to be below 150 parts per million of bicarbonates. 1 pint took it to 148, so we're at that threshold. A quart per 100 gallons of LV took it clear to 0. So that's where I come in saying, yeah, if you wanted to, you could go up to a quart and that would be fine, but around somewhere between 24 to 32 ounces would be probably the use I'd recommend for this particular water in this test. If you don't have access to water testing, be very comfortable that you know that if you just put a pint in 100 gallons, it's probably going to cover you. So LV does a nice job, like I said, of spray coverage. This is showing it how much it reduces surface tension and helps spray coverage. A lot of times we measure the surface angle of the spray droplets. So when we compare LV to a typical 80-20 or 90-10 type surfactant, it's doing a better job of breaking surface tension than most of your standard non-ionic surfactants. The use rate's very low. You can use 1 to 4 pints, but I don't think there's going to be anybody, at least here in the Midwest, that's going to go above a quart. So I think somewhere between 16 to 32 ounces in 100 gallons would be more than adequate. It comes in quarts and gallons. However, the gallons are too large of a package, and because of the acid in it, it's more difficult to transport with some of the hazmat things. But the quarts don't have that hazmat issue because of the smaller package size. So predominantly, most people are using the quarts. Also, it makes it easier for measuring and mixing into your tank. So quarts are going to be the most popular size of use. When we look at cost, a lot of people ask about what do these things cost. In this case, if you're spraying through a low-volume sprayer, the low-volume sprayers typically spray at a carrier rate of 10 gallons per acre. If you're adding 16 ounces into that, it's about a penny 1,000 square feet. So it is not a great impact to the cost per 1,000 that you're looking at, but it's giving you much better efficacy, and it's addressing the water conditioning aspect, tying up bicarbonates and lowering the pH. If you're spraying up at a gallon per 1,000 or thereabouts, around 40 gallons per acre, now we're up in that 4 to 5 cents range. But again, the benefits of getting 20–30% better efficacy just through the surfactant, along with the water conditioning aspect. Another area of concern might be drift. We look at basically looking at the sprayer on the bottom, there's that fog or that mist, and if you've ridden on a commercial sprayer and you make the turn and you have that mist hit you in the face, you're having to clean your glasses off and you can smell and taste what you're spraying. That fog is never going down to the target. It's not doing anything for you. It's possible it could drift off depending on what you're spraying. Drift may be of a bigger concern than others, but what we're after is like what we're seeing on the top, where all of the spray is going down to the target so that we get the most efficacy, we get more of that active ingredient going to work for you. We have a product called Border 2.0, and it is designed for drift control, but it also has surfactants in it. So it reduces the amount of small spray droplets, so we ensure that it's going to hit the turf or the ornamentals. It's giving you better spray coverage because it has a good surfactant in it, and it improves retention on the leaf. And I have a video that I'm going to show in a little bit that dramatically shows that. When we look at it on spray paper, water by itself versus water with Border 2.0, you can see that you're getting much better spray coverage. So how do we quantify what's going on in that mist that's coming out behind your sprayer? We look at droplet size, and you can go to your spraying systems, your TJET catalogs. You can evaluate the nozzles that you're running, and it'll give you a range of what percent of the droplets are in different sizes, and that can vary also with pressure. But what we're trying to get above 100 microns, and probably targeting more like 200 microns. And this is a study done at University of Illinois in their ag engineering, showing how far does a droplet travel. So if your boom height, and typically on a commercial sprayer in our market, we're looking at about a 20-inch boom height on most turf applications. So when we measure a 200 micron size droplet, and 100 microns, just for a reference, 100 microns is the thickness of a piece of hair. Okay, so a hair on your head is 100 microns thick. So we're talking about twice the thickness of a piece of hair. That droplet can travel 25 inches. So we're good at 200 microns. At 150, we're getting about 18 inches of travel. At 100 microns, maybe 10. 50 microns are only traveling 3 or 4 inches, and 20 microns less than an inch. So what does that mean? Well, that means that the more that you have in that 20 micron size, you could be losing up to like 48% of your spray. So the more fog that's out there, you're thinking, boy, I'm getting good spray coverage, but it's not making it down there. And that is subject not just to drift, but it's also just evaporating into the atmosphere, and all that active ingredient could be wasted. And that means money wasted. So what we're trying to do is decrease or eliminate that wedge of lost product and lost performance. So this is a video that I'm going to use this slide as an introduction, but it shows border hitting the leaf surface and spreading out and staying on the leaf surface versus the untreated running off or bouncing off the leaf as the droplets shatter. So with that, I'm going to do this video, and we'll see how this plays for us. But we're showing droplets hitting a leaf surface, and you can see that some of them are bouncing off, some of them are running off, and you're not going to get the efficacy that you would. And then we'll go to a split screen. This is with border added. The border, and if you're doing this through a backpack, you can see this yourself. When they hit, they spread, they stay on the leaf, you're going to get so much more efficacy. And here's a single droplet hitting. Again, the coverage, the retention on the leaf, that's keeping what you're applying foliarly on the foliage. So we did research to document what that's doing. This was at Ohio State, looking at dollar spot control. Here's chlorothalonil again at 1.8 ounces. We see that when we added the border to it, we look at percent increases over the daconil by itself without border. We have 47% better efficacy out of just by adding border to that fungicide application. So products that we have to reduce drift, Border 2.0 is probably our Cadillac product. We also offer Compound, which I mentioned earlier, that's a surfactant. It has an oil in it for drift and addresses the pH and bicarbonates. It's not quite as good of a drift retardant, but is very effective. And then we have our Chevy, if you will, is Direct. Direct is a drift retardant, but it is an older technology. Like most other drift products on the market, it makes bigger droplets, but they don't do anything for the retention on the leaf and won't perform to the level that Border would do. So kind of a good, better, and best example here, with Border 2.0 being the best. We have a new product that we're launching also called Penetrate Eco. It also has an oil in it. It's not as good as Border on drift control, but it does have a good surfactant, and it's got a fatty acid for better penetration. And the other interesting aspect of Penetrate Eco is it's labeled for aquatics, and it's an OMRI rated product. We have a couple OMRI products that you could discuss with your Testman rep if you're interested. So in our surfactant line, we've got a whole host of products, and it becomes very confusing. Do you just want to address the pH and bicarbonates? Do you want to have something that's a spreader sticker for rainfastness? Or do you need to have the ChemStick LPH that does both the spreader sticker with the pH buffering and tying up bicarbonates? Sink, Border 2.0 we covered, Compound. I would say you just need to consult with your Testman rep for which product is best for you. What are your needs? I think with this list of products, we're pretty much able to cover those needs and help you to improve all those sprays so that you have better results, less callbacks in lawn care, better disease control for your ornamentals, better overall efficacy on your golf courses. I think we've got a pretty strong lineup here, and they can help you identify what might fit your program best. With that, I'll say thank you. I don't know if there's any questions that popped up during this. Lauren, are there any questions that have come up?
I don't see any questions, Chip. I do want to make sure that everybody was able to see your entire presentation. If there's any feedback that anybody could provide in the chat, that would be great. Our internet went down here for about 2 or 3 minutes, and I know that Zoom is cloud-based, but since I am the host, I just wanted to make sure that everyone was still able to see your entire presentation.
You mean I could have been just talking to myself?
Well, I was able to come back in, and all of our participants are still here on the webinar,
Beautiful.
so that's good to see.
Beautiful.
And yeah, and we did have one chat. They were able to see everything, so awesome. Thank you so much for that feedback.
Very good.
Yeah, and I don't see any open questions, so if anybody does have any questions in the future, please feel free to contact Tessman or your rep or Chip for that matter. And
yeah, I've got my number and email up here, so they feel free to email me or call me if you'd like.
Perfect. So thank you everybody for being here on our webinar, and we look forward to future webinars with you. Thank you.
Thank you.